Okay, let's dive into something incredible. We're going to decode a secret language, one that's being spoken inside your body right now. And this isn't just some fun fact. This language is what makes the difference between shaking off a minor cold and ending up with a serious illness. I mean, really think about this for a second. Your immune system, it's not one thing, right? It's not like your heart or your liver. It's more like this massive, decentralized army of trillions of cells, and they're all scattered throughout your entire body. So how in the world do they all get on the same page to fight off, say, a single virus? How does one cell in your throat basically tell a whole squad of killer cells way over in a lymph node, hey, it's go time? Well, the answer, it turns out, lies with these tiny but incredibly powerful little proteins. Think of them as the couriers, the radio signals, the field commanders for your entire immune system. And they have a name. They're called cytokines. And the name itself is actually a huge clue. It comes from the Greek cyto, which means cell, and kinesis, which means movement. So these proteins literally cause movement in cells. They are the chemical words that one immune cell uses to tell another one what to do. To give orders, to call for backup, or to just sound the alarm. So this communication, it doesn't just happen in one way. It works over different distances. Sometimes a cell will release a cytokine just to give itself a little pep talk. That's called autocrine action. It's like talking to yourself. More often, though, it's sending a message to its next-door neighbors. That's a paracrine signal, kind of like yelling across the fence. But in a real, full-blown emergency, it can blast these cytokines out into the bloodstream to get the whole body involved. And that's endocrine action, which is a lot like how a hormone works. Okay, so if cytokines are a language, then like any language, they've got to have rules, right? A kind of grammar. And understanding these four main rules is absolutely key to getting how our immune system can be so incredibly precise one moment and then just overwhelmingly powerful the next. All right, first up, we've got a rule called pleiotropy. Basically, this means one single message, one word, can have totally different meanings depending on who's listening. So take the cytokine interleukin 4. It can go to a B cell and say, hey, start making antibodies. But that exact same message can go to a T cell and a mast cell and tell them to start multiplying. So same signal, completely different results. It's just super efficient. Next, there's redundancy. And this is exactly what it sounds like. It's the system's built-in backup plan. Let's say you need a B cell to start multiplying pronto. Well, you don't just have one way of telling it to do that. You've got interleukin 2, interleukin 4, and interleukin 5. They can all deliver that exact same command, proliferate now. This is a great failsafe, because it means that even if one of those signals gets blocked for some reason, that absolutely critical message still gets through. Then there's synergy. This is all about teamwork. It's that classic idea where 1 + 1 doesn't just equal 2, it might equal, 10. For example, getting a B cell to switch the type of antibody it's making, that's a really complex job. A single cytokine like IL-4 or IL-5 can kind of nudge it in the right direction, sure, but when you get them working together, their combined signal is so much more powerful, and it's what really makes that crucial switch happen. And finally, rule number 4 is antagonism. You can think of this as the off switch or the brakes on the system. Because, just as important as starting a huge immune response is knowing when to shut it down. So here, one cytokine can literally cancel out another's message. For instance, a cytokine called interferon gamma can come along and completely block that antibody switching instruction from IL-4. This gives you a beautiful system of checks and balances that keeps the whole thing from just going haywire. So, you put all these rules together, and what you get is this beautifully orchestrated immune response. It's amazing. But when you push this communication network to its absolute limits, well, it can become a real double-edged sword. Okay, so in a normal, healthy response, what you get is something called a cytokine cascade. It's basically a controlled positive feedback loop. Here's how it works. An activated T cell sends a cytokine signal to a macrophage, right? It says, get to work. Then that macrophage gets activated and signals back to the T cell, which in turn activates more T cells. You see how this works? It's this brilliant amplification, this chain reaction that lets a tiny initial response just explode in size and completely overwhelm an infection. But what happens when that cascade just doesn't stop? Well, that's when you get a cytokine storm. All that careful communication, it breaks down. It turns into this deafening roar of signals. The positive feedback loop just spirals out of control, and it causes this massive, system-wide inflammation. We're not talking about a targeted attack anymore. This is pure chaos. It's a system-wide panic that starts damaging your own healthy tissues and can even lead to organ failure. It's incredibly dangerous. And look, this isn't just some rare freak event. When this cytokine language gets messed up, when it's dysregulated, that is at the absolute heart of so many common diseases. Think about something like rheumatoid arthritis. That chronic, painful inflammation, that's being driven by way too much production of cytokines like TNF-alpha and IL-6. This is exactly why getting a handle on these little messengers is so critical for understanding both health and disease. But okay, here's the good news. This is where it gets really hopeful. Because we understand this secret language, modern medicine is actually learning how to hack the code. We're figuring out how to edit the conversation that's happening between our own cells. And we can do this in two main ways. It's like having a volume knob. On one hand, we can block the signals. We could design drugs, these incredible things called monoclonal antibodies, that basically go in and intercept specific cytokines. It's like telling an overactive immune system, hey, quiet down. Or we can do the opposite. We can boost the signals. We can give a patient lab-made cytokines like interferon to help a sluggish immune system fight way harder against things like cancer or nasty viruses. And I want to be clear, this is not science fiction. This is happening right now, in clinics and hospitals today. The drugs that block TNF-alpha, they have absolutely revolutionized how we treat rheumatoid arthritis. We use IL-2 to supercharge a patient's own immune system to go after certain types of cancer. We use interferon beta to help manage multiple sclerosis. Every single one of these treatments is a direct result of us finally learning to speak this language of cytokines. So let's end with this thought. We've really just scratched the surface. We're just beginning to understand the vocabulary and the grammar of this incredibly complex language inside of us. And as we get more and more fluent, we're going to move beyond just treating symptoms. We're moving toward actually directing the immune response itself. So the big question is, what new conversations will medicine help us have with our own bodies? What diseases could we completely rewrite the story of? The possibilities, really, are just starting to open up.